Now we're going to take a look at another example. As you can see on the screen, we have a beam. Now on this beam, we have a roller support at point A and we have a pin support at point B. So meaning at point A, we are going to have one unknown force. So this is AY. As usual, we are going to assume this to be acting upward, while at point B, we are going to have two unknown forces. So this is BY acting upward, while BS to the right. So we are going to assume this direction. Now, if you take a look at the distributed load, we have a complicated looking load. But don't worry, all you need to do is you need to decompose this load. How can we decompose this load? If you decompose this load, you are going to have a rectangle with a triangle. So we are going to have a rectangle with a triangle. As you can see, we are having a big rectangle with a small triangle. Now, what you need to do is you need to replace this distributed load. You need to replace this with an equivalent force. Now, we are going to have two forces. On the rectangle, we are going to have an equivalent force F1, and this is going to be at the middle because we are having a rectangle. So this is going to be at the middle. So we are going to have this equivalent force at the middle. So this is F1. While we're also going to have an equivalent force F2 on this triangle. So this is going to be F2. Now, we need to calculate these forces. So how can we calculate this? We are going to take the area of the triangle and the area of the rectangle. So the area of the rectangle is going to be 22 feet because this is the length of the rectangle. Then multiply by the height, which is 0.05 kip per foot. So this is going to be 22 multiplied by 0.05. This is going to give us 11 kip. So F1 is equal to 11 kip. So this is the force. Now we also need to calculate. We also need F2. Now how can we calculate F2? We just need to find the area of this triangle. The area of this triangle, as you can see. So this is going to be 11. Then multiply by the height of this triangle is going to be 0.02 because 0.07 minus 0.05 is going to give us 0.02. So this is the height of the triangle. So this is 0.02. So this is 0.02 multiply 11 then divided by 2. This is going to give us 0.11 kip. So F2 is equal to 0.11 kip. So this is the second force. Now you need to know that F2, the distance from F2 to the left of the triangle is going to be 1/3 of the length. So this is going to be 1/3 of the length. So this is 1/3. While from the force F2 to the right of the triangle, this is going to be 2/3. So this is 2/3. Now what we need to do, we just need to calculate AY, BY, and BS. Now you need to know that BS is going to be equal to 0 because we don't have any horizontal force on this beam. So BS is automatically equal to 0 because we don't have any horizontal force. So let's calculate for AY and BY. Now we are going to take the moment, summation of the moment at point B because we want to find AY. So we're going to take summation of moment at point B at the pin support. So we're going to say summation of moment at point B is equal to 0. So we are going to say the movement in the counterclockwise direction is positive, while the movement in the clockwise direction is negative. So the first force is AY, and because AY is acting upward, and if we apply a force upward, it's going to try to rotate this beam in the clockwise direction. So because it is clockwise, meaning we are going to have a negative value. So this is negative AY. Then we also need the distance. What is the distance? The distance is going to be 11 plus 11, which is 22 feet. So this is the distance from AY to the pin support. So this is 22 feet. So this is multiplied by 22. Now we have F2. As you can see, F2 is 0.11 kip. And this is acting downward. Because it is acting downward, it is going to try to rotate the beam in the counterclockwise direction. So because it is counterclockwise, meaning it is positive. So this is positive 0.11 kip. We also need the distance. So what is the distance? The distance is going to be 2/3 of 11 feet plus 11 feet. So 2/3 of 11 feet plus 11 feet, this is going to give us 18.3 feet. So this is multiplied by 18.3 feet. Now, what about F1, 11 kip? If we applied a downward force, 11 kip on this beam with relative to this point B, it is going to try to rotate this beam in the counterclockwise direction. And because this is counterclockwise, meaning it is positive. So this is positive. This is positive 11 kip, then multiplied by the distance. So what is the distance? The distance is going to be 11 feet. So this is 11 feet from the force to the pin support. So this is multiplied by 11 feet. So because we don't have any additional force, meaning this is equal to 0. So what we need to do, we just need to find AY. So if you use your calculator, you're going to get AY is equal to negative 11.09 kip. So this is going to be the value of AY. So AY is equals to negative 11.09 kip. As you can see, we are having a negative value. Because we're having a negative value, meaning our assumption is wrong, meaning this force is acting downward because we are having a negative value. So let's find the remaining force, By. Now, how can we find By? We are going to say summation of the forces in the vertical direction is equal to 0. So this is going to be summation of the forces in the vertical direction, Fy, is equal to 0. So we're going to say all the forces acting upward is positive, while all the forces acting downward is negative. So the first force we have is AY. As you can see, AY is negative 11.09 kip, and this is acting downward. So this is going to be negative 11.09 kip. Then the next force we have is F2, which is 0.11 kip, and this is acting downward. So negative 0.11 kip. Then the next force is 11 kip. As you can see, this is acting downward. So this is going to be negative 11 kip. Then the next force we have is By. This is what we want to find, and it is acting upward. So this is going to be positive. So this is positive By. Because we don't have any additional vertical force, this is equal to 0. So all we need to do, we just need to solve for By. So negative 11.09 minus 0.11 minus 11. This is going to give us negative 22.2. So this is negative 22.2 kip plus By is equal to 0. So all we need to do, we just need to take this to the other side of the equation. So this is going to be By is equal to 22.2 kip. So By is equal to 22.2 kip. So this is the force. As you can see, we are having a positive value. So because we are having a positive value, meaning our assumption is right. So meaning this force is acting upward. So these are the forces that are required in order for this beam to be at equilibrium. Bs is 0, Ay is 11.09 kip, and it is acting downward, while By is 22.2 kip, and it is acting upward. Now, if you want to check if your answer is correct. There is a quick way you can check if your answer is correct. All you need to do, you need to take the summation of all the forces needs to be equal to 0. If it is equal to 0, meaning your answer is correct. Let's quickly do the check. We're going to say summation of all the forces in the y direction need to be equal to 0. So the first force we have is AY, and AY is negative 11.09. So this is negative 11.09 kip. Then the next force is 0.11 kip, as you can see, and this is downward, so meaning this is negative. So this is negative 0.11 kip. Then the next force we have is 11 kip, and this is acting downward, so this is negative 11 kip. Then the next force we have is BY, and BY is positive, and it is BY is positive, it is acting upward, so this is positive 22.2 kip. So we need to make sure this is equal to 0. So let's calculate this. So this is negative 11.09 minus 0.11 minus 11 plus 22.2. So this is indeed equal to 0. So because this is equal to 0, meaning our calculation is correct. So these are the forces that are required to keep this structure at equilibrium. So if you enjoyed this video, don't forget to give this video a thumbs up and subscribe to the channel. Also, if you have any question, make sure you ask me any question in the comment section below. Thank you.